JEE Advanced 2025, Mathematics, Question 13. Let us visualize the three differential equations. Each one is a first-order linear ODE of the form dy dx equals f of x times y. The solution involves integrating the coefficient function. We will keep these equations as reference. Here is the question. For all x greater than 0, let y1, y2, and y3 satisfy the three given differential equations with initial conditions y1 of 1 equals 5, y2 of 1 equals 1/3, and y3 of 1 equals 3 over 5e. Find the limit as x approaches 0 from the right of y1 times y2 times y3 plus 2x divided by e to the 3x times sin x. The key concept is the first-order linear ODE. For an equation of the form dy dx equals f of x times y, the general solution is y equals c times e to the integral of f of x dx. The constant c is determined by the initial condition. Our strategy will be to solve each ODE, multiply the three solutions together, and then evaluate the limit. Step 1. Solve for y1. The equation is y1 prime equals sin squared x times y1. Integrating sin squared x gives x minus sin x cosine x, all over 2. So y1 equals c1 times e to the power x minus sin x cosine x over 2. Using y1 of 1 equals 5, we find c1 equals 5 times e to the negative 1 minus sin 1 cosine 1 over 2. Step 2. Solve for y2. The equation is y2 prime equals cosine squared x times y2. Integrating cosine squared x gives x plus sin x cosine x over 2. So y2 equals c2 times e to the power x plus sin x cosine x over 2. Using y2 of 1 equals 1/3, we get c2 equals 1/3 times e to the negative 1 plus sin 1 cosine 1 over 2. Step 3. Now we multiply y1 and y2. Notice a beautiful simplification. The exponents combine, x minus sin x cosine x over 2 plus x plus sin x cosine x over 2 simplifies to just x. The sin cosine terms cancel out. The constants give us 5 times 1/3 times e to the negative 1, which is 5 over 3e. So y1 times y2 equals 5 over 3 times e to the power x minus 1. Step 4. Solve for y3. The coefficient function is 2 over x cubed minus 1, which equals to x to the negative 3 minus 1. Integrating, we get negative 1 over x squared minus x. So y3 equals c3 times e to the power negative 1 over x squared minus x. Using y3 of 1 equals 3 over 5e, we get c3 times e to the negative 2 equals 3 over 5e. Solving this gives c3 equals 3e over 5. Step 5. Now we compute the product y1 times y2 times y3. We have 5 over 3 times e to the x minus 1, multiplied by 3e over 5 times e to the negative 1 over x squared minus x. The constants 5 over 3 and 3 over 5 cancel to give 1. The exponentials combine, e to the x minus 1 times e to the negative 1 over x squared minus x simplifies to e to the negative 1 over x squared. This is a remarkably clean result. Step 6. Now we evaluate the limit. As x approaches 0 from the right, e to the negative 1 over x squared tends to 0 extremely fast, much faster than any polynomial. So the numerator becomes e to the negative 1 over x squared plus 2x, which approaches 2x. The denominator is e to the 3x times sin x. As x tends to 0, e to the 3x tends to 1, and sin x is approximately x. So the denominator approaches x. Therefore, the limit equals to x over x, which is 2. The answer is 2. G-tip: when you see a product of solutions of differential equations, always look for simplifications in the exponents. Sin squared plus cosine squared equals 1, so their integrals combine nicely. For limits involving e to the negative 1 over x squared, remember it goes to 0 faster than any power of x. Also, for small x, sin x is approximately x and e to the ax is approximately 1 plus ax. These standard limit approximations save valuable time in the exam. Like and subscribe for more JEE Advanced solutions at MAGPIEHUB.